Hi student. So you can see we are going to solve one numerical that is based upon to find out the capacity factor and the load factor of particular power plant. Now for that the given data is that the given equation question you can see the draw load curve and load duration curve and calculate load factor and capacity factor for power supplies. The following load is consumer. Okay, following load is given to the consumer or the power will be supplied to the consumer. You can see with respect to time load is given for 0 to 6 hours 20 kilowatt of load is given, 6 to 10 50 kilowatt, 10 to 12 60 kilowatt, 12 to 16 40 kilowatt, 16 to 20 80 kilowatt, 20 to 22 70 kilowatt, and 22 to 24 hours 40 kilowatt has been provided to the consumer. Now we have to first of all draw the load duration curve and load curve. Okay, both are the different curves. You can see first of all we are going to draw load curve. Okay, you already know how to draw the load curve. You have to take time which is in hours on x-axis. So this will be the time, and here the load consumed or the load provided to that particular customer, that is in the kilowatt. So you have to write down here. Now on x-axis we are going to take a time 3, 6, 9, 12, then 15, 18, 21 and 24. Okay, you can write down, you can take a scale as your you can take the scale of 3 hours. Then you will take the load on y-axis, you can take it as 40, 80, or you can say you can use the 20, 40, 60, 80, etc. Okay, now you have to draw the load curve, simple load curve. You have to draw the load consumed by the consumer with respect to time. So first 6 hours, for first 6 hours the load is 20 kilowatt. So you can draw a simple line. You can see I will draw with the green color. You can saw you have to draw a simple straight line or the horizontal line which is consist 20 kilowatt of load for first 6 hours. So this will be the first 6 hours. Then 6 to 10, then next 4 hours we required 50 kilowatt. So here should be a 9 somewhere. So you have to write down, you have to increase the load from 20 to 50. Okay, so it will be the less than 60, and you have to write down, draw this one for 4 hours. So it will be the up to 10. Okay, so likewise you can draw the curve. You already know how to draw it. I will just draw it from 10 to 12 it will be the 60. So again increase up to the 12 for 2 hours, then 12 to 16 it is again 40. So it will be reduced up to 40 and for 4 hours. Okay, then again 16 to 20 80 hours the maximum load will be carried out or consumed by the particular customer, so up to 80, and this is for 4 hours. Okay, after that 20 to 22 70 hours. So again it will be the reduced up to the 70 hours, and it is for 2 hours 70 kilowatt load will be given. Then 22 to 24 40 kilowatt of load is required. So that's how you can draw the particular load curve. Now the area below this load curve, it will gives you the total energy consumed by that customer. Okay, it will gives you, if you find out the area below this load curve, it will gives you the total energy consumed by the customer. Okay, in 24 hours. Similarly there will be a load duration curve. Okay, that also we are going to draw the load duration curve, which is which very similar to the load curve. Okay, so here load duration curve, and as we know the difference is that we have to arrange this load in descending order on load duration curve. Okay, other things are very similar. Again we have to take the time on x-axis, load on y-axis. Okay, so first of all we have to write down, or we have to draw this particular load core in descending order. Okay, so highest will be the 80. So we have to first draw 80 for 4 hours. So it will be from 0 to 24 hours. This one is the 12 hours. So for the first 4 hours there will be a maximum load. Okay, then next maximum is 70 hours, or the 70 kilowatt, which is for 2 hours. So again it will be for 2 hours. Then next will be 60 for 2 hours. Again it will reduces 60 for 2 hours. Then next is 50 for 4 hours. Again it will reduces 50 for 4 hours. It is for 4 hours. Then next is 40. Okay, 40 for this 2 hours and this 4 hours. So it will be the total 6 hours. 40 kilowatt will be required. So for 6 hours you can write down 40 kilowatt, and after that 20 kilowatt, that is the lowest requirement or the energy consumed by the customer. So it will be the lowest one. Okay, so this will be your load duration curve. You can write down, or just so indicates the duration by using the dotted lines. Okay, so you will understand. Now the main, the difference between, you can see here in load duration curve, we are going to plot this load variation from in descending order. Okay, now the main similarities in these two particular curves are that the area below this curve is always same as the area below the load curve. Okay, means the total energy consumed is not going to be changed. Total energy consumed by the customer, it will be the constant. Only this shape or the arrangement of the load, it's going to be changes. So that is our first bit of the numerical. Second bit, we have to find out that to calculate the load curve and calculate the load factor, calculate the load factor and to calculate the capacity factor. Second one is the capacity factor. So first of all, to calculate the load curve, you should know what is average load and what is the peak load, or the average load and the peak load you must know. Now to calculate the average load, you will see the definition of average load means it is the total energy consumed divided by total time. Okay, means average load required, or the average energy consumed by the customer for 24 hours. Okay, we have to take average. This is the variation. Okay, with respect to time, the load required for the consumer, it going to be variate, but we have to find out the average load. So for that, total energy consumed by that particular customer divided by total time required. So total energy consumed means what? That is the area below this load curve, right? Area below this load curve, or area below the load duration curve. So that you can find out just by multiplying. Here for 6 hours, first 6 hours 20 is required. So the 20 into 6 plus next 4 hours 50 is required. 50 is the load required. Now that is 4 into 50. Then next will be 2 into plus 2 into 60. Okay, next will be 2 into 60 plus then 4 into 40 plus 4 into 80 plus next will be 2 into 70 plus remaining last one is 2 into 40. Okay, that is your total energy consumed by the customer divided by total time. Total time is 24 hours. Okay, so you can calculate the average load. Average load will be, if we add all those curves, you will see the total to average load we will get, that is 47.5 kilowatt. Okay, so that is your average load. So continuously for 24 hours we require to produce, or we require to provide 47.5 kilowatt of load. Now we have to find out the load factor. Now load factor you can easily find out, that is the average load, that is 47.5 divided by what is the peak load. Now from this given data you will find out the peak load is 80 kilowatt. So you have to write down here 80. So if we do the maths, you will find out the load factor will be is around 0.59. Okay, so that is the load factor of that particular power plant. Now next is to find out the capacity factor. Okay, now capacity factor, you will know the average load divided by plant capacity. Now we already know what is average load, that is 47.5 kilowatt. We have to find out the plant capacity. Now here, that is the tricky point or the tricky concept of this particular numerical. Okay, to find out plant capacity is not directly given in this problem. We have to find out, or we have to consider the plant capacity as per our convention. Now you can see the minimum load required is 20. Okay, so 20 kilowatt it is the minimum load required, highest will be required 80. Now we have to plan, or we can generate, or we can consider one particular plant which is having the capacity of a total 80 kilowatt, right? So for achieving the 80 kilowatt, we can install 420 kilowatt of different generators. Okay, or you can also install 60 kilowatt of one generator of 60 kilowatt, second generator is 20 kilowatt, or you can install one generator of 80 kilowatt. It is totally depends on you. Now we have to add, or we have to install another one generator which is required, because we can consider that generator as a backup plan or the reserve plant capacity. Because whenever we design any particular or install any particular 80 kilowatt plant, sometimes what will happen, because as life is increasing, or it's as we its life is or time going, because of the maintenance and the other problems, its capacity will decreases or its efficiency will decreases. So for whole life it does not going to produce 80 kilowatt. So for that we have to add one reserve capacity to that particular power plant. Now here we can use 20 kilowatt of reserve capacity. Okay, so we are going to add 20 kilowatt into the maximum requirement, that is 80 plus 20, that will be the 100 kilowatt. So the total capacity of that particular power plant must be the 101. So that is the part. Now here you can consider 120, 90, anything. It is depends on you. But particularly whenever we going to add reserve capacity, just see the minimum load and you can add that load into the maximum load. You will get the reserve capacity. It is totally depends on you how to consider the plant capacity. Okay, now we will going to consider 100 kilowatt at a plant capacity. So by using that one, capacity factor will be average load 47.5 divided by 100 kilowatt, so it will be around 0.475. So that's how you can solve the to find out the capacity factor if low capacity of the thermal power plant is not given in the numerical. It is totally depends on you how much reserve capacity you are going to use, and by using that one you can calculate the capacity or the capacity factor.